Great. So I'm at a little disadvantage because I'm not sure who's on the call. So I'll just assume that I haven't met at least some of the people who are on the call. So I'll give you a little bit of background. I am a pediatric physical therapist who came back from my PhD because I felt like there wasn't enough evidence to guide our interventions. And so I have always loved working with kids and families, and so I still do that in my research. And I'll give you a little overview about how I do that. But also I, as a parent and as somebody that's always worked closely with families, my research philosophy is really family focused. So I try to make participation in our research as easy and convenient for families as possible. So if you come by my lab, it will not look like a data collection lab. And that's because we do most, if not all, of our data collections in the communities. Sometimes people come to us if they are coming from a distance or they have a messy house and don't feel like having us come to their house that day. They don't feel like cleaning. They'll tell us that they prefer to come in. So most of the time we are out in the community seeing people, and then we bring our data back to the lab where we process code and analyze it. So the philosophy that underlies my research is that motor actions, all the physical activities that we do every day, really help form the foundation for learning. And that's really especially true for infants and young children. So there's a whole wealth of developmental science literature that supports the idea that your everyday activities, moving your body, moving around, gesturing with people, interacting with objects, using your visual attention, controlling your posture to look at things and observe events, all of those things are really critical for learning. And so I write grant proposals to try to advance motor as well as cognitive development. And now I'm starting to collaborate with other folks like Gio Marini, who's in communication sciences at UDEL, and Roberta Golenkoff, who's in education at UDEL, to try to also use movements and early interventions to improve language outcomes for kids. So my research program has 3 primary focuses. And the first is really just to understand developmental processes, because if we understand how typical development works and how development may be different in kids with disabilities or motor impairments, then we can figure out which aspects, with which variables we can manipulate to change the developmental outcomes. So that is always something that we're doing, is trying to just characterize what are developmental trajectories for kids with typical development and kids with delays. The other thing that we do then is try to develop interventions. And this is the biggest part of the research that happens in my lab. So people always ask me if I miss the clinic coming back and being a researcher. And I probably would if we didn't have actually intervention-based research. But what we do is really focus on changing behaviors and outcomes for kids. So it's very clinical. So the first type of intervention, we have 2 types, and those would be technology-based interventions and activity-based interventions. And so I'll talk about the wearable technology interventions first. And so I actually have an affiliated appointment in fashion and apparel studies, which I never would have guessed. Is a place that I would have been ages ago when I started off at UD. But I started realizing that a lot of the technologies, most of the technologies that we apply in rehabilitation are worn or somehow placed on the body. And if we're going to do that, we really need to consult and collaborate with people who know how to make things that are comfortable and aesthetically appealing to people, as well as functional to meet the broad needs of those people, so that people will actually use the things we want them to use. So now I work a lot with folks in fashion, and we are working on a range of low to high tech projects. So an example of a low tech project would be that kids out in the community, many kids with severe motor impairments have a lot of trouble with oral motor control. And so they have salivation, sometimes excessive, and they can't control it. They can't keep it in their mouth. They can't swallow it. So it ends up dripping down, causing problems on their mouth and their neck and their chin. And they wear these really outdated looking old bib-like things. And if you're a high schooler or a middle schooler, you don't want to wear a bib. So I have a master's student who's working on making a solution. So we do textile testing, look at different solutions. We're trying to get samples from Gore, trying to figure out different materials that we could use and making them stylish. So stylish looking infinity scarves or whatever styles the kids are into. So that's a really low-tech solution that still brings in like fashion engineering to create solutions to improve lives for kids. Then we have a bunch of mid-range, I would say medium tech solutions, and those would be some of the supportive solutions. So we have made a soft ankle support for kids. We did this past year, trying to make an alternative for hard AFOs for kids that want to have a break from the AFOs for things like wearing cleats for soccer or ballet shoes for dance, or dress shoes for confirmation or the 8th grade dance. So we made sort of a corset-like solution for the ankle using metal ribbing and supports, and that worked out really well. So, and we do scientific testing of the solution afterward to see how it functions compared to the alternative solution. And then another example of our mid-range solution that's been more well-publicized and better studied in our lab because it's older is the Play Skin Lift exoskeletal garment. And so this is a shirt that has supportive inserts under the to help kids with weakness move their arms and interact and play because all those are important for cognition. And we have studied that garment with 17 kids who have had arm weakness due to a condition called arthrogryposis. And we've also studied it in 9 infants from Christiana's NICU who have had brain injuries or preterm birth. And we studied it to see what are the assistive effects, and we find that it assists movement. So we see changes within a session in your function when you're wearing it. And then we studied to see the rehab effects. So we show across time that it changes your outcomes, your independent performance. It makes you stronger. It makes you better able to function on your own with your upper extremities. So those are all mid-range examples. And a high-tech example would be our next level of the Play Skin Lift, because the Play Skin Lift works for kids 3 and under, but it doesn't work for longer arms or heavier arms. It also doesn't allow users to control the level of support. And so the Play Skin Air is a pneumatic exoskeletal garment, and that will allow users to control it. It can lift a heavier arm. So that is a bigger challenge, and we are doing a lot of bench testing before we put that on people. And right now we have air bladders that can lift the full weight of an 11-year-old male's arm and control the arm through different areas in space. And we have control mechanisms using compressed air that users could wear that are not that big or bulky or heavy that could be integrated within the garment. So that's the technology-based intervention. And it's important to note that those technology-based interventions are paired with activities. So technologies are not a solution on their own, but they are a tool that we use along with our rehab activities for kids. So our activity-based interventions I left for last because that is what my pilot project is that's funded under SL. And so we have done a lot of work in my lab looking at ways that we could educate parents to change developmental outcomes for children. And one example of the study that we have right now is the Start Play study, and that is sitting together and reaching to play. So it's taken my previous research looking at ways that we can advance reaching abilities in young infants and their cognitive outcomes, subsequent cognitive outcomes. And we are applying that for kids with mild, moderate, or severe motor delays. And that study is funded by the Institute for Education Sciences and is in a no-cost extension year. So we're analyzing the data set and finding that we are seeing really nice changes in cognitive outcomes for kids. Interestingly, when we compare to business as usual early intervention physical therapy, there's not a lot of difference in the motor outcomes. So PTs are doing a good job at addressing motor, but they're missing something, and that's using the motor ability for problem solving. So we are working on ways to teach people, it's not just about walking. It's not just about transitioning or reaching. It's about allowing kids to use those skills to problem solve, how to get around objects or over objects or to get to hidden objects. And those are really important cognitive constructs that can be incorporated in physical therapy to have greater benefits for kids across developmental domains in terms of their outcomes. And the last thing I'll mention is the activity-based intervention that is funded by the ESTEL program and the CTR, and that is my intervention to very early educate parents how to handle and position their kids and how to introduce toys into play with their kids to advance their outcomes. And this is based on my work that has shown that if at 2 months of age, we start to encourage parents to let kids hold their heads on their own more, hold their trunks on their own more, put them in prone on their stomachs, put them upright more often, then we start to see that those kids have lasting changes in development. If we ask them even to do this just 15 minutes a day for 3 weeks, they have changes up through a year later. So they sit earlier, they crawl earlier, they walk earlier, and that is because we think that these head and trunk control requirements are really important for those future skills. And so that, to me, is what's really fun about pediatric PT, is you figure out, again, you track development, you figure out what contributes to the emergence of a skill, and then you try to go back way before that skill emerges and change the developmental trajectory so you can make that skill emerge even earlier. In terms of the object play, if we introduce toys earlier in development within reach for infants, and we help them grasp it and explore it, they start to learn about the world much earlier, and we see cognitive benefits months after. So they understand how objects can be used as tools to control other objects, and those types of cause and effect relationships, understanding that is really critical for development, especially if you're talking about kids with severe motor disabilities, like in our Start Play study. Some of those kids we're employing similar tactics and finding that some of those kids with very severe motor delays, those types of cause-effect learning relationships are not addressed in business as usual PT, and those are really critical because those are the kids that are going to need that understanding for communication. They are not yet able to speak, many of them, and just understanding that you can use your reaching to select an object, to gesture to one thing or another, or to control communication devices, that's really critical for them to become independent. So the ESTEL project is supporting us to look at ways that we could employ these types of interventions, and we're also merging them with language interventions that Roberta Golenkoff and her colleagues have been using for young children to advance their language outcomes and making a comprehensive intervention. And there's no early comprehensive intervention like that looks at ways to advance integratedly advance motor, cognitive, and language outcomes for kids. So that is a general overview of my research program. We are always looking, like right now, we are looking for infants who are less than 5 months of age, who are either full-term and healthy or preterm and at risk for developmental delays for the pilot project to gather data. So that's probably our biggest challenge. So if anybody has suggestions or tips about ways to go about that, getting those infants, that would be really helpful. Thank you very much for listening.